So to set up one of these are the bill of materials we need. First of all, we need a pre-drilled tube. Tube is made out of food-safe polypropylene. This is really important because roots will be in contact with the plastic, so we don't want it to leach any harmful chemicals. So that's one bit. Then we have these hoses. These hoses will be used to pump water from the barrel through the pump and into the hose leading up to the top. So these are made of natural rubber, which is also very important. It's a very food-safe material. It's used for laboratory equipment, so you can't really go wrong with that. In addition, it has to be non-transparent because both of these will be out in the open light in the air, and if it's transparent, then we'll have algae growing on the inside, which is something we do not need. So this is a silicone rubber hose. This one will be used internally inside the pipe from the pump up to the top to the sprayer. Since it's not exposed to the light, there's no danger of algae growing there, and we can use a much more mechanically sound material, which is silicone. So that's what we're using there. Alternatively, these can be replaced with silicone tubes as well on the outside, but for now I'm sticking with natural rubber. So here we have a sprayer. Sprayer comes on top of the tube. Water is pumped inside and then sprays below, which is something I'll just show you in the video right now. This is our hydroponics system sprayer. The sprayer has dual function. First of all, it is a source of water for the roots of the plants, but also equally important, it absorbs a lot of oxygen as the water flows through. This oxygen is important for the plant's growth and aeration of the water, so it never becomes stale. Here we can see a simple demonstration of how this works. As the water is flowing through, the oxygen gets sucked from the top, and you can see how many bubbles actually are within the water flowing through. These are the latest pods I'm using. This is the 5th version I made so far, and there are two types. This one is made out of PLA. It's a biodegradable material which can last for a couple of years, so I'm using these for not for perennials but for seasonal plants, so we have some kind of control to check after every season if it's still worth using or we need new ones. And this one is made out of nylon, so it's perfectly both of these are food-safe materials in this regard, but this is nylon. This is like a permanent, very strong, very durable material. These are very difficult to make, so it's a bit tricky to print them. So, but all of these are 3D printed, and files will be, I'll link the files in the description so you can download them online. So the pods will have Rockwool inside. So the system works by planting seeds directly in the system, so you don't need to plant them outside and then replant them into the system. You can simply put some Rockwool inside, put a seed onto the Rockwool, and the seed will sprout and start growing roots into the tube. For this to happen, I have an incision on the inside, which after the Rockwool is put in can expand outwards, so it's kind of sticking out into the tube, allowing the roots to simply start growing downwards into the tube itself. Okay, so in these previous towers, I had an issue of water leaking next to the pods, which is sometimes causing me issues. So you see, we have some algae growth, and then we have these streams of nutrients on the outside of the tube, which doesn't look very, very appealing. So in order to resolve this, this is the solution I came up with. We have these 3D printed rubber inserts, which come paired with nitrile O-rings. These will fit into the pre-drilled holes and will serve as an airtight, as a watertight seal, which I can actually show. Okay, with my bloody hands. So these would go inside. Okay. With the O-ring on all sides to fit snugly, so the water can't leak. And then we'll have the next thing coming in. Pods go into the pre-drilled holes with those rubber O-rings. They fit in snugly, keeping things very, very tight. So you just jam them in and it all very solidly sticks together. So it's a durable construction. Obviously we need a pump. I tried different types of pumps, but these are all brushless pumps, which means they're completely silent, there's no noise, and they're quite powerful. This one, for instance, is 18 watts, has 800 liters per hour of flow rate, which is important to get a high pressure, and it has maximum head of 3 meters. These pillars are around 2 meters, so we have 1 meter play, which should be enough to get enough of pressure and flow into the system. These are more powerful pumps, and this pump is used for 2 systems at the same time. So it's again, both of them are 12 volt pumps, but this one has 5 meter head. So the rotor spins faster and there's more pressure in the system. So that's very usable, and I'm using this one for the strawberries because strawberries are more than 3 meters tall. The pillar is more than 3 meters tall, which needs a powerful pump to be able to pump the water all the way up. So as these are 12 volt pumps, we need a power adapter. So this converts the AC current into the DC current, 12 volts. These are very standard, they're regular, there's nothing. So this is the barrel I'm using. It's a fermenting barrel, which means it's completely inert, it's very food safe, and it can be used for a very long time without any kind of degradation. These barrels come in blue, which is nice because again, we don't want any light coming in. So inside has to be completely void of light. But unfortunately, the blue is very attractive to the sunlight and it heats up quite rapidly. So I discovered that the best way to deal with this is to paint them white. So the white color reflects the sunlight and keeps them cool throughout the day. So there's no sun inside and there's no heat inside. It's kept cool and dark in the barrel, which is the most important thing. So these barrels come with a lid, which has a rubber seal. So these are made to be hermetically sealed once closed, which isn't really our concern because we have to have the system open. So we drilled a hole on top, so the water dripping from the tube can drain back into the barrel. But then we have this nice ring around, which clamps the whole thing into place. Like this, and then we can clamp it shut. So it's very solid now. But if you want to service something, if you want to take, I can show actually, if we want to take it out, as we have here, you can simply undo it, expand the ring, and then we can take the whole thing out with those lovely roots. Back in. This is an adapter I printed, which will serve as a bond between the lid and the tube. Previously I did separate inserts, so I have four of these, but this is firm enough, but it does wobble a bit, so I wanted to make it a bit more solid. So if we see this one here, it's able to, it's firm, it won't break, but it's able to wobble. So I'm trying to make it a bit less wobbly by having a complete ring around the tube. So we've attached the lid to the tube, tried to make it as square as possible so it's straight up, which seems to be okay. So the other end of the silicone tube goes into the inlet of the sprayer, which goes in like this. Needs a bit of force to get it in, but that's about it. Okay, so when the sprayer is ready, we drop the hose in. Okay, come on. Put the lid on top for now. We don't have to worry about it not sitting well, because we still have to make attention. Pulling the rubber down. Okay. Right, take the hose, get it out through one of those holes we drilled into the lid, like this. Okay. So we have transparent tube on the inside, but as soon as the water goes out, it has to go through non-transparent tube into the pump below. So the second tube, the water inlet tube, goes into the other hole. We can put it in from above, push it all the way down until it gets to the bottom. Okay, actually might be easier if I just pull it. Okay, like this. Come on, don't be shy. Okay, like this. Okay. So this is a hose which serves as a water intake hose from the bottom of the barrel into the pump. So it goes into the inlet of the pump. And the other hose is the water going from the pump all the way up to the sprayer. So we connect it to the exit of the pump. Okay. So the system could have been made simpler by putting the pump into the barrel, onto the bottom of the barrel. But there's an issue with that, because pumps produce heat, and when water is heated, the oxygen goes out, the water becomes stale. So we want to avoid heating up the water as much as possible. That's the reason why I'm leaving the pump outside, complicating things a bit, but it's well worth it. Okay. It needs to draw in water first to be able to work. So I do this the old-fashioned way by sucking it out. And then connecting the hose. Okay. It's all tight. There's no leaks. And that's it. Pretty straightforward. I think anyone can really make it. And if you need any help, just let me know. I'll try to answer it.